right, hey, good morning, freshmen. This is Martineau here. Ms. Mangiarelli running the camera live from the House of M. So what we're doing today is we're doing a demonstration of Lab 4A. So you should have that sheet in your Google Classroom. And Lab 4A is just continuing our discussion on work. And in this case, we're going to be looking at work done with pulleys. So the idea for today is that we're going to be looking at input work versus output work in a machine known as, in a simple machine known as a pulley. So just a quick reminder that work is force times distance, right? So what we have in our system here is that we have these pulleys, right? And we have a string which we are going to pull down on, in which case is going to lift up this pulley. But what you'll notice here is that the number of strings that we have is going to somehow affect the amount that we have to pull down with. If it didn't, what's the point of having a machine? I mean, that's the whole idea, is that we want to have the machine do some work for us, or at least make the burden less. So the way we're going to do this is we have to measure two things. We have to measure the input force, and we have to measure the output force. We have to measure the input distance, and we have to measure the output distance. So what's input and output? Let's take a look. The input force is the force that I am applying to the machine. And the way we're going to measure that is with this thing. It's called a spring scale. Maybe you've seen this before, maybe you haven't. But what a spring scale does is it measures input force. So here's one way to look at it, right? If I pull on it, the spring goes up and down, and it measures different amounts of force. So one way to do that, this has nothing to do with the lab, but I can put a weight on here, and according to this spring scale, this weight weighs roughly 2 newtons, because 2 newtons of force are being applied to this spring scale. And that's absolutely true. This is about 200 grams, right? So when you do the math out, 0.2 kilograms times 9.8, it's about 1.96 newtons. So it's right on target, right? So this is going to be measuring the input force. The output distance, the input distance is the distance that I'm going to pull this rope down. And that's what we're going to be measuring. So we're going to be measuring the input force with the spring scale, and we're going to be measuring the input distance. That's how far this string in my hand right here gets pulled down while I'm doing the work. Okay, let's talk about the output force. The output force is the force that the machine is exerting on the object I'm looking to lift, right? So in this case, the output force is going to be the weight of these 4 steel plates. And for every trial in this lab, it's going to be 10 newtons. The output distance is also going to be the same. We're always going to pull this thing up to, where are we doing this from? From the top of the bottom?
Of the
Okay.
weight.
So we're going to pull this thing up from the bottom of the blue weight up to this point on the stand that says 30 centimeters. So the output distance, the distance that the weight is being lifted up, is always going to be 0.3 meters. So that makes that side of the data table really, really easy, right? The output force is always going to be 10 because we're always lifting a 10 Newton weight. The output distance is always going to be 0.3 meters because we're always going to lift it 0.3 meters. The only thing that's going to change is how much I pull with and how far this string goes down. Let's look at another part of the setup. We got these yellow strings and we have these red strings. What we're going to find is a relationship between the number of strings pulling up the pulley, pulling up the weight, and the
Mechanical advantage.
I wasn't sure if we did that.
Yeah.
So, I'm sorry, I drew a blank. It's efficiency we don't do.
Right.
So, and the mechanical advantage. I'm not going to go into detail on that. That's what the lab's going to do. So, here's the deal you got to remember. We're only counting the number of yellow strings. We're not counting the red strings. The red strings are only there to support this weight right here, and I'll prove it to you. Once I apply some force to this yellow string, these red strings go completely slack. So this weight right here is not being held up by these red strings the moment I pull on the yellow one. So we don't count the red strings as the number of strings. We only count the yellow strings because that's what's applying the external force. So ignore the red strings when you're doing your quote unquote string count. Okay, so right now if I'm looking at it, this is 1. Okay? And what we're going to see here is as we kind of move along with the lab, the number of strings that are supporting this weight are going to increase. Also to note that, and I got to be very clear here, we're only counting this as one string. We're not counting this one as one of the strings. We're only counting this string that's pulling up this weight. So to be clear, only one string is pulling up this weight. The red ones don't count, and the one that I'm using does not count. All right. I think that's pretty clear, right? All right. So what we're going to do here is that we're going to go through our trials. We got 6 trials. So these are going to be trials 1, 3, and 5. That's going to be trials 2, 4, and 6. As we go along, I will pull on each of the weights with my spring scale.
I'm just turning this, sorry.
It's okay. We're going to pull on the weights with the spring scale, and we're going to note how many strings we have. So here we go for trial uno. Got the spring scale. All right.
I'm going to try to hold this.
Okay. I can do it too. Oh, no, because I'm going to measure.
Yeah.
All right. So ready? So here it comes. And we're going to do this. And I'm going to pull, where's the Newton side? There's the Newton side. And we're going to start from... So let's see, I'm gonna measure from the top of the hook.
Yep.
So that's about 0. And here we go.
So you're going the bottom of the blue to the 0.3.
About right there.
Yep.
So we've got 10 newtons, and I pulled it 32 centimeters.
Okay.
10 newtons, 32 centimeters. On trial number 1, 10 newtons, 32 centimeters. All right, going back.
And we did put the data in the data table already.
Should I not read it? You want me to read it still?
No, I think maybe just focus on the fact of what's happening with the force and the distance, maybe.
Sounds good to me. Okay, so that was 1 string. Let's count the strings. 2 strings. Okay, and then we're going to take this spring scale. Okay, and we're going to pull this down. So where's the 3? Where is it?
It'll be here.
There, okay. Okay, so notice we have 2 strings supporting my tackle, my block. It's block and tackle.
Yeah.
And you should notice that I had to pull this a little further than the last one, right?
About where are you?
I'm about 56 centimeters, right? So I pulled that's more than the last one with 2 strings. Cool? All right, so now we're going to let that one go. All right, and we're gonna take this one off. I'm gonna put this down. Now what we're gonna do is I have to, in order to get to my 3-string situation, I've got to take my string and I've got to feed it through the lower end of the pulley and up and over like this.
Neighbor's cat. Since this is gonna be all over YouTube.
Oops. Gotta make sure that it's on the pulley itself here. Here we go. Okay.
So now we have, let's see. Yep.
Yep. And
Pulley there. And we have 2 pulleys up there.
Okay. And now let's count the strings. We've got 1, 2, 3 strings. And so now what I'm going to do is we're kind of measuring it here. So I'm going to take this guy, I'm going to take my meter stick, I'm going to pull up to the 30 centimeter mark, make sure I'm on the centimeter side. Which is about right here. So notice.
It's very obvious this time you pulled a lot more string.
Yeah, I'm all the way down here to the countertop. Right, so that's going to be our deal. And the data for that is in the data table. Okay, but it's definitely less force.
What about how much do you have in newtons now?
I've got about 2.5, no, 3
So we
newtons.
started at 10 and now we're down to 3.
Now we're down to 3. All right.
All right.
So this is coming back up. Take that off the top. We're going to do the same thing over here. We're going to feed some string through. Oops. Yeah. Okay. Shoot. Scheiße.
There you go.
Okay.
So you got 2 pulleys down there.
Yeah.
And 2 pulleys up there.
And we got 4 strings.
Yep. So
All
the
right.
number of strings always equals the number of pulleys.
Yep. Okay. So we got. I take this guy up here. Take my meter stick. Might be a moot point. Here we go. Ready?
I'm going to come on this
sorry
side.
about that.
No, it's okay.
Oh, wait, where's the hole? There?
Yep.
Okay. So now I'm below the tabletop.
About how many newtons?
We're looking at neighborhood of about 2. Okay. So here we go, coming back down.
So I noticed the string keeps getting longer every time you add a pulley.
Yep.
And your newtons, your amount of force you're putting in, keeps decreasing.
That is correct. All right, so here we go. We're going to trial 5. This is when it gets hairy.
Uh-oh.
Okay, here we go. Feed the string through.
And if we did this in class, we'd have stations set up 1 through 6. So you wouldn't have to feed the string through like Mr. Martineau's doing. We'd have it all set up for you. There you go.
Okay, so let's take a look. We've got it.
Well, let's see. 3 pulleys there. And 2 pulleys there, so it's 5 pulleys.
And let's look at the strings.
That's 5 yellow strings.
5 yellow strings.
Yep.
All right, here we go. I'm not even going to put the meter stick up.
Yeah.
I know what's going to happen. Ready?
And go ahead. Actually, you want me to hold it?
I'm holding it.
Okay.
I'm good. Okay, so we got... I actually took more.
Are the strings in the pulleys?
Nope, we lost one.
Yep, that's why. Yep.
All right, hold on a minute.
Excuse me. Excuse me. Is it the right one being pulled?
I don't know.
No, it's this one.
Okay. I'm pulling on the wrong one. That's why. Hold on a minute. We knew the outcome did not work out well. So we just simply redo it. Let's put that back there. I put it on the wrong one.
So we have a bunch of loops at the top, and Mr. Martineau chose poorly.
I chose poorly. All right, here we go.
Okay, there you go.
Let's try that again. Oh yeah, that makes more sense.
Yep.
There you go.
Yeah, there you go. So very obvious this amount of string is getting longer, so the input distance is getting longer.
And we're under 2 newtons. I can't really read it that well, but
Okay.
it's under 2 newtons.
All right. And we have one more, and I'm actually
now it's getting tricky.
going to put the books. So I stacked up a bunch of, well, some great books here, clinical laboratory methods. Let's see, while Mr. Martineau's doing that, we got fundamentals of clinical chemistry, biology, physics, clinical lab methods, all kinds of great stuff. And Mr. Martineau's doing the string again. This is our, well, that's our neighbor's cat.
Again? Okay, so
All
we
right.
got that.
So let's see, what do we have? We got
3 pulleys.
3 pulleys there.
3 pulleys here.
So 6 pulleys
and 6 strings.
6 strings.
All right, here we go. Make sure we get the right one. Should be this one.
All right.
Okay, here we go.
That shouldn't topple. It should be okay. I don't.
Something happened.
Yeah.
Yeah, I lost the pulley.
All right. When the strings come out of the pulley, then the machine isn't working the right way. So we got to make sure that the strings are right in that little indentation in the pulley. Wait a minute.
No, I lost that
There
one.
we go.
All right, let's try this again.
I think you're good.
Okay, here we go.
Okay,
Try
ready?
that again. Is it there?
Right there.
Yeah.
All right, so you're basically down to the floor.
Yep. Yeah, I'm under 2 newtons.
Okay.
And we lost that. Okay, cool. So let's take a look, right? You should have seen some patterns with the input work being done. That is to say the input force and the input distance. That's what I was pulling. And on the pulley that was going downward, right? The input work was always the same. It was the same amount of weight and the same amount of what? Oh, the same amount of weight and the same amount of distance, right? So what we want to try to do is find out a relationship between the input work, the output work, the number of strings, then the distance, input distance, and the input force. And all of that is kind of all arranged for you and organized for you in the lab. So having said that, get at the lab, do the calculations, make sure you have your calculations are correct. Make sure you answer your questions in high school level answers. Making sure that you cite work is force times distance, and citing data and all that stuff.
Capital letters,
punctuation, all those
complete
things,
sentences,
that
please.
make us adults. So, having said that, signing off from the House of M, I am Mr. Martineau. That is Miss Mangiarelli. That is the cat who we have named Tunces, though that's probably not his name. And we will see you next time. Stay safe. Goodbye.